Dear students, my name is Dr. Iregowda. I am working as a senior lecturer in Government College, Helanka. Today, I am going to discuss one very important chapter of your chemistry, that is called electrochemistry. So, in electrochemistry, based on the concepts, you have to attend the CET questions. But very important thing is, you should know the correct way of understanding the subject. ಅದರಿಂದ ಯಾವುದೇ ಒಂದು ಸಿ ಇ ಟಿ ಕ್ವಶನ್ಸ್ನ ಅಟೆಂಡ್ ಮಾಡುವಾಗ ನಿಮಗೆ ನಿಮ್ಮದೇ ಆದಂಥ ಸಬ್ಜೆಕ್ಟ್ನ ನಿಮ್ಮ ಮನಸ್ಸಿನಲ್ಲಿ ಇಟ್ಕೊಂಡಿರಬೇಕು. ಆ ಸಬ್ಜೆಕ್ಟ್ನ ಕಾನ್ಸೆಪ್ಟ್ ಬೇಸಿಡ್ ಮೇಲೆ ನೀವು ಆ ಸಿ ಇ ಟಿ ಕ್ವಶನ್ಸನ್ನು ಅಟೆಂಡ್ ಮಾಡಬೇಕಾಗುತ್ತೆ. ಎಲೆಕ್ಟ್ರೋಕೆಮಿಸ್ಟ್ರಿನಲ್ಲೂ ಅಷ್ಟೇ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್ ಚಾಪ್ಟರ್ ಇನ್ ಕೆಮಿಸ್ಟ್ರಿ ಇದು. those who are attending the all questions from electrochemistry, 100% they will get the success. ಅದರಿಂದ let us discuss that electrochemistry in detail. See, in the definition of electrochemistry itself, there is a explanation. Electro means electricity, chemistry means chemical reactions. So, electrical energy can be converted into chemical energy, or chemical energy can be converted into electrical energy. Therefore, in electrochemistry, we are studying the interconversion of electrical and chemical energies. So, this is the important concept. See, a device is required to convert electrical energy into chemical energy or chemical energy into electrical energy. Those devices are named as the electrochemical cells. There are two types of electrochemical cells. One is the galvanic cell, another is the electrolytic cell. Galvanic cell is a device from which electricity can be produced from chemical reactions, but electrolytic cell is a device in which electrical energy is converted into chemical energy. Therefore, we have to concentrate more on galvanic cells and electrolytic cells. Then we can take the applications of the galvanic cells. They are called batteries and fuel cells. Now let us know the correct information regarding the galvanic cell. As I told you, galvanic cell is a device from which electricity is produced by spontaneous chemical reactions involving oxidation and reduction. That spontaneous word is very important because from the non-spontaneous chemical reactions we cannot produce electricity from chemical reactions spontaneously. So that now we have to know galvanic cell by taking Daniell cell is the example. Daniell cell, you know, it is made up of two electrodes. One is the copper electrode, another is the zinc electrode. Copper electrode means copper rod is dipped in copper sulfate solution. Zinc electrode means zinc rod is dipped in zinc sulfate solution. These two electrodes are connected by the special device called salt bridge. Salt bridge is a device used to connect the two electrodes. It eliminates the liquid-liquid junction potential. So, one more function of that salt bridge is it maintains the electrical neutrality. It maintains electrical neutrality. Now, after connecting the two electrodes by the salt bridge, copper electrode acts as the cathode, zinc electrode acts as the anode. ಇಲ್ಲಿ ನಿಮಗೆ ಯಾವ ಬೇಸಿಸ್ ಮೇಲೆ ನಾವು ಕಾಪರ್ನ ಕ್ಯಾಥೋಡ್ ಆಗಿ ತಗೊಂತೀವಿ, ಜಿಂಕ್ ಅನ್ನ ಆನೋಡ್ ಆಗಿ ತಗೊಂತೀವಿ ಅಂದ್ರೆ ಬೇಸ್ಡ್ ಆನ್ ದಿ ಸ್ಟ್ಯಾಂಡರ್ಡ್ ರಿಡಕ್ಷನ್ ಪೊಟೆನ್ಷಿಯಲ್ ವ್ಯಾಲ್ಯೂಸ್. ಸ್ಟ್ಯಾಂಡರ್ಡ್ ರಿಡಕ್ಷನ್ ಪೊಟೆನ್ಷಿಯಲ್ ವ್ಯಾಲ್ಯೂಸ್ ಲೆಸ್ ಇದ್ರೆ ಅದು ಆನೋಡ್ ಆಗಿ ವರ್ಕ್ ಆಗುತ್ತೆ. ಸ್ಟ್ಯಾಂಡರ್ಡ್ ರಿಡಕ್ಷನ್ ಪೊಟೆನ್ಷಿಯಲ್ ಮೋರ್ ಇದ್ರೆ ಅದು ಕ್ಯಾಥೋಡ್ ಆಗಿ ವರ್ಕ್ ಆಗುತ್ತೆ. ಅದಕ್ಕೋಸ್ಕರ ದಿ ಎಸ್ ಆರ್ ಪಿ ಆಫ್ ದಿ ಕಾಪರ್ ಎಲೆಕ್ಟ್ರೋಡ್ ಈಸ್ 0.34 volts ಇರುತ್ತೆ. ಎಸ್ ಆರ್ ಪಿ ಆಫ್ ದಿ ಜಿಂಕ್ ಎಲೆಕ್ಟ್ರೋಡ್ ಈಸ್ -0.76 volts ಇರುತ್ತೆ. ವೆನ್ ದಿ ಆರ್ ಕನೆಕ್ಟೆಡ್ ಬೈ ದಿ ಸಾಲ್ಟ್ ಬ್ರಿಡ್ಜ್, ಜಿಂಕ್ ಎಲೆಕ್ಟ್ರೋಡ್ acts as the anode, copper electrode acts as the cathode. This is the base to decide which is anode, which is cathode. Now, once after deciding the anode and cathode, you know the reactions takes place at anode. Anode at which oxidation takes place. Cathode at which reduction takes place. During oxidation, commonly metal is converted into metal ion. During reduction, metal ion is converted into metal. Therefore, we can write the off cell reactions and then complete net cell reaction. In the case of Daniell cell, zinc is Zn is converted into Zn2 plus by losing 2 electron. In the case of Copper electrode means cathode. Copper 2 plus ions are converted into copper. Therefore, by adding these two reactions, we will get zinc plus copper 2 plus giving rise to zinc 2 plus copper. So here, during oxidation, removal of electron takes place at anode, so that removed electrons are moving from anode to cathode through the external circuit. So this is very important. The movement of electrons is called electricity. That electricity is measured in terms of electromotive force, EMF. That is the difference between the electrode potential of the cathode and electrode potential of the anode. So now, after knowing the movement of electrons from anode to cathode, we can calculate the cell potential. Cell potential is equal to E naught of cathode minus E naught of anode. E naught of cathode means E naught of copper minus E naught of zinc. So E naught of cathode is 0.34 in the case of copper, minus 0.76. There you will get 1.1 volt of EMF in the case of Daniel cell. So this is already we have discussed in the theory classes, but based on this very important CET questions ನಾವು ಸಹ ಡಿಸ್ಕಸ್ ಮಾಡಬಹುದು. ಇಲ್ಲಿ electrons are moving from anode to cathode, so that cathode should receive the electron given by the anode, so that cathode acts as the positive electrode in the case of Daniel cell, and zinc electrode means anode acts as the negative electrode. But in the case of electrolytic cell, cathode is the negative electrode, anode is the positive electrode. But in the case of galvanic cell, cathode develops positive charge, anode develops negative charge. And also you should know some information regarding the cell notation. Commonly, as per the IUPAC rule, anode must be in the left hand side, cathode must be in the right hand side. So between the two, we are going to write the salt bridge. Dipped is indicated by single slash, salt bridge is indicated by double slash, so that we can write the symbolic notation of the Daniel cell. So Zn is dipped in Zn2 plus. So this is the anode. Again, copper is dipped in copper 2 plus. So this is the cathode. So these two are connected by salt bridge. If it is the standard Daniel cell, you have to mention 1 molar concentration. Here also 1 molar. So here 1 molar. So this is the anode, this is the cathode. So that you can write the off-cell reaction. Zn is converted into Zn2 plus by losing 2 electrons. Copper 2 plus 2 moles of electron to form copper. So that net cell reaction is Zn plus copper 2 plus giving rise to Zn2 plus copper. This is the net cell reaction. So that you can calculate the cell potential. Cell potential can be calculated by E naught of cell is equal to E naught of copper minus E naught of zinc. So copper value you know that 0.34 minus 0.76 volts. So that plus 1.1 volt. After knowing the information regarding the Daniel cell, in some cases we are going to use even inert electrodes also. Why we are using inert electrodes and you should know some information. Suppose if you take iron 2 plus, Fe2 plus and Fe3 plus ions, both are in the solution state. In such cases, one supporter, that is called adsorbent, is required. In such cases, we are using inert electrodes on the surface of which the reaction takes place. But to measure the SRP of any other electrode, we are going to use the standard hydrogen electrode. Standard hydrogen electrode potential is assumed to be taken as 0, so that symbolic notation of the sheet, that is also very important for CET. So this is the symbolic notation of platinum. So this is a hydrogen. Hydrogen is a gas. Hydrogen gas is adsorbed on the surface of platinum. So pressure must be 1 bar. Then dipped in H plus ion. Concentration of that H plus ion must be 1 molar. So this is the symbolic notation. By using that standard hydrogen electrode, all other electrode potential can be measured experimentally. So now After knowing the SRP of all other electrodes, you should know some information regarding the SRP values. ಆ ಇಂಪಾರ್ಟೆನ್ಸ್ ಅಲ್ಲಿ lesser SRP element acts as the good reducing agent, higher SRP element acts as the good oxidizing agent, lesser SRP element is more reactive, higher SRP element is less reactive. ಈ ಕಾನ್ಸೆಪ್ಟ್ಸನ್ನು ಯೂಸ್ ಮಾಡಿಕೊಂಡು ನಾವು ಎಲ್ಲ ಕಡೆಯಿಂದ ನಾವು ಅದನ್ನ SRP ವ್ಯಾಲ್ಯೂಸ್ನ ಯೂಸ್ ಮಾಡಿಕೊಂಡು ನಾವು ಟ್ರಮೆಂಡಸ್ ಅಪ್ಲಿಕೇಶನ್ಸ್ ಬಗ್ಗೆ ಡಿಸ್ಕಸ್ ಮಾಡ್ತಾ ಹೋಗ್ತೇವೆ. ಈ SRP ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು ಅಂತ ಅಂದರೆ ಸ್ಟ್ಯಾಂಡರ್ಡ್ ಹೈಡ್ರೋಜನ್ ಎಲೆಕ್ಟ್ರೋಡನ್ನ ಯೂಸ್ ಮಾಡ್ಕೋತಾ ಇದ್ದೀವಿ. ಸ್ಟ್ಯಾಂಡರ್ಡ್ ಹೈಡ್ರೋಜನ್ ಎಲೆಕ್ಟ್ರೋಡ್ನ ಯೂಸ್ ಮಾಡಿಕೊಂಡು SRP ಆಫ್ ದಿ ಅದರ್ ಎಲೆಕ್ಟ್ರೋಡ್ ಕ್ಯಾನ್ ಬಿ ಕ್ಯಾಲ್ಕುಲೇಟೆಡ್. ಬಟ್ ಎಲೆಕ್ಟ್ರೋಡ್ ಪೊಟೆನ್ಷಿಯಲ್ ಡಿಪೆಂಡ್ಸ್ ಆನ್ ದಿ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಆಫ್ ದಿ ಅಯಾನ್ಸ್. ಹಾಗಾದರೆ ಡಿಫ್ರೆಂಟ್ ಕಾನ್ಸಂಟ್ರೇಷನ್ಸ್ಲಿ ಹೌ ಟು ಕ್ಯಾಲ್ಕುಲೇಟ್ ದಿ ರಿಡಕ್ಷನ್ ಪೊಟೆನ್ಷಿಯಲ್ ಅನ್ನೋದು ಮೇಜರ್ ಕ್ವಶನ್ ಆಗುತ್ತೆ. ಅದಕ್ಕೋಸ್ಕರ ಆ ಪ್ರಾಬ್ಲಮ್ನ ಸಾಲ್ವ್ ಮಾಡ್ಕೊಳ್ಳೋದಕ್ಕೆ ಕಾಮನ್ಲಿ ವಿ ಆರ್ ಯೂಸಿಂಗ್ ನರ್ಸ್ಟ್ ಈಕ್ವೇಷನ್ನ ಯೂಸ್ ಮಾಡ್ಕೋತೀವಿ. So what is that Nernst equation ಅಂತಂದ್ರೆ in 3 different ways we are going to write the Nernst equation. So E is equal to E naught minus 0.0591 divided by N log of 1 divided by metal ion concentration. So this is the Nernst equation. It is used to calculate the single electrode potential at different concentrations. Again, by using the same Nernst equation, we can calculate the cell potential at different concentrations. So what is the equation we can use to calculate the cell potential antandre? So E cell is equal to E naught of cell. Already we know that how to calculate the E naught of cell. E naught of cell is equal to E cathode minus E anode. So minus 0.0591 divided by N log of concentrations of the products divided by concentrations of the reactants. So this is the Nernst equation used to calculate the cell potential at different concentrations. Now the major issue is how to calculate the value of N. N ಅನ್ನು calculate ಮಾಡೋದು very important for CET also. So what we can do is N ಅನ್ನು calculate ಮಾಡೋದಕ್ಕೆ ಆಕ್ಸಿಡೇಷನ್ ರಿಯಾಕ್ಷನ್ನು ರಿಡಕ್ಷನ್ ರಿಯಾಕ್ಷನ್ನು ಸಪರೇಟ್ ಆಗಿ ಬರ್ಕೋಬೇಕು. ಆಮೇಲೆ ಅವೆರಡನ್ನು ನಂಬರ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ನ ಈಕ್ವಲೈಸ್ ಮಾಡಿ ಅದನ್ನು ಆ್ಯಡ್ ಮಾಡಿಕೊಂಡ್ರೆ ನೆಟ್ ಸೆಲ್ ರಿಯಾಕ್ಷನ್ ಬರುತ್ತೆ. ಇನ್ ಅಡಿಷನ್ ಟು ದಟ್ ಯು ಕ್ಯಾನ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ದಿ ವ್ಯಾಲ್ಯೂ ಆಫ್ N. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್, ಇನ್ ದಿ ಕೇಸ್ ಆಫ್ ಡೇನಿಯಲ್ ಸೆಲ್, zinc undergoes oxidation to form zinc 2+ by losing 2 electrons. Again, copper 2+ ions undergoes reduction by gaining 2 moles of electron to form copper. When these two are added, 2 electron get cancelled. Therefore, Zn plus copper 2+ giving rise to Zn2+ plus copper. Illi how many electrons get cancelled annade the value of N. Therefore, N is equal to 2. This is how we can calculate the value of N. ಆಮೇಲೆ ಪ್ರಾಡಕ್ಟ್ಸ್ ಕಾನ್ಸಂಟ್ರೇಷನ್ಸು ರಿಯಾಕ್ಟೆಂಟ್ ಕಾನ್ಸಂಟ್ರೇಷನ್ಸ್ ಬರಿಬೇಕು ಅಂತಂದರೆ ಕಾಮನ್ಲಿ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಆಫ್ ಎನಿ ಸಾಲಿಡ್ ಎಲಿಮೆಂಟ್ ಈಸ್ ಟೇಕನ್ ಆಸ್ ಯೂನಿಟಿ. ಸೊ ಇದು ಸಾಲಿಡ್ ಎಲಿಮೆಂಟ್ ಆಗಿರೋದ್ರಿಂದ ಇದ್ರದ್ದು ಯೂನಿಟಿ ಇರ್ತದೆ. ದೇರ್ ಫಾರ್ ಇನ್ ದಿ ಕೇಸ್ ಆಫ್ ಡೇನಿಯಲ್ ಸೆಲ್, ಪ್ರಾಡಕ್ಟ್ಸು Zn2+ ಕಾನ್ಸಂಟ್ರೇಷನ್, reactants copper 2+ concentration. Therefore, we have to give the Zn2+ and copper 2+ concentrations to calculate the cell potential. ಅದನ್ನು ನಾವು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ಕೊಬೋದು. ಸೊ ಈಗ ವ್ಯಾಲ್ಯೂ ಆಫ್ N ಅನ್ನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿ ಕಲ್ತ್ಕೊಂಡಾದ್ಮೇಲೆ ಲೆಟ್ ಅಸ್ ಗಿವ್ ದಿಸ್ ರಿಲೇಷನ್ ಟು ದಿ ಸ್ಟ್ಯಾಂಡರ್ಡ್ ಫ್ರೀ ಎನರ್ಜಿ ಚೇಂಜ್. ಸ್ಟ್ಯಾಂಡರ್ಡ್ ಫ್ರೀ ಎನರ್ಜಿ ಚೇಂಜ್ ಅಂತ ಅಂದರೆ delta G naught is equal to minus NF E naught of cell. We are going to calculate the E naught of cell. N you know how to calculate. So F andre Faraday constant. Its value you know very well, 96,500 coulombs. So that you can get the value of delta G naught. Where we are getting delta G naught is negative andre cell still it is working spontaneously anta. Therefore delta G naught is negative. That process is spontaneous. When delta G naught is equal to 0, all reactions are at equilibrium, the cell is almost dead. Suppose if you increase the EMF of the cell, ನಾವು ನಾನ್ ಸ್ಪಾಂಟೇನಿಯಸ್ಲಿ ಇನ್ಕ್ರೀಸ್ ಮಾಡಿದಾಗ ಡೆಲ್ಟಾ ಜಿ ನಾಟ್ ವ್ಯಾಲ್ಯೂ ಮೇ ಬಿ ಪಾಸಿಟಿವ್ ಬರ್ಬೋದು, ಅದು ಪಾಸಿಟಿವ್ ಬರ್ಬೋದು, ನೆಗೆಟಿವ್ ಬರ್ಬೋದು, ಮತ್ತೆ ಝೀರೋನೂ ಬರ್ಬೋದು. ಝೀರೋ ಬಂದಿದೆ ಅಂದರೆ ಡೆಡ್ ಆಗಿದೆ ಅಂತ, ನೆಗೆಟಿವ್ ಬಂದಿದ್ರೆ ಸ್ಟಿಲ್ ಇಟ್ ಈಸ್ ವರ್ಕಿಂಗ್ ಅಂತ, ಪಾಸಿಟಿವ್ ಬರ್ತಾ ಇದೆ ಅಂದರೆ ಇಟ್ ಈಸ್ ರೀಚಾರ್ಜಿಂಗ್. ಲೆಟ್ ಅಸ್ ಡಿಸ್ಕಸ್ ದಟ್ ಕಾನ್ಸೆಪ್ಟ್ ಇನ್ ದಿ ಬ್ಯಾಟ್ರೀಸ್. ಸೊ ಇಷ್ಟೆಲ್ಲ ಈ ಕಾನ್ಸೆಪ್ಟ್ಸನ್ನ ಇಟ್ಕೊಂಡು ನಾವು ಲೆಟ್ ಅಸ್ ಟೇಕ್ ಇನ್ ವಾಟ್ ವೇ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಆಸ್ಕ್ ದಿ CET ಕ್ವಶನ್ಸ್ ಇನ್ ದಿ CET ಎಕ್ಸಾಮಿನೇಷನ್. CET ಎಕ್ಸಾಮಿನೇಷನ್ನ ಕ್ವಶನ್ಸ್ ತಗೋಬೇಕು ಅಂದರೆ ಯು ಶುಡ್ ಕೀಪ್ ಆಲ್ ದಿ ಇನ್ಫಾರ್ಮೇಷನ್ ಇನ್ ಮೈಂಡ್ ವಿತ್ ಕಾನ್ಸಂಟ್ರೇಷನ್ನು. ಆ ಕ್ವಶನ್ ಪೇಪರ್ನ ನೀಟಾಗಿ ಓದಿ ಆ ಕ್ವಶನ್ನ ಅರ್ಥ ಮಾಡಿಕೊಂಡು ಆಮೇಲೆ ಅದಕ್ಕೆ ಆನ್ಸರ್ ಮಾಡೋದು ತುಂಬ ಒಳ್ಳೆಯದು. ಈಗ ಒಂದು ಅಷ್ಟು ಸ್ಯಾಂಪಲ್ ಕ್ವಶನ್ಸನ್ನು ನಾನು ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡಿರೋ ಕಾನ್ಸೆಪ್ಟ್ ಮೇಲೆ ತಗೊತೇನೆ. ಫಸ್ಟ್ ಒನ್ ನೋಡಿ, and I will read this question very slowly. Identify the location of oxidation in an electrochemical cell. Option A, the anode. Option B, the cathode. Option C, the electrode. Option D, the salt bridge. ನಾನು ಬಿಗಿನಿಂಗ್ ಅಲ್ಲಿ ಹೇಳಿದ್ದೀನಿ, ಆಕ್ಸಿಡೇಷನ್ ಟೇಕ್ಸ್ ಪ್ಲೇಸ್ ಅಟ್ anode, reduction takes place at cathode. Therefore, the location of oxidation in an electrochemical cell is anode. That option is correct. Second question is important related to that Daniel cell. Which one of the following is not a function of the salt bridge? ಅಂದರೆ ಸಾಲ್ಟ್ ಬ್ರಿಡ್ಜ್ನ ಫಂಕ್ಷನ್ ಅಲ್ಲದೆ ಇರೋದನ್ನ ನಾವು ಹುಡುಕ್ಬೇಕಾಗಿರೋದ್ರಿಂದ ಐ ವಿಲ್ ರಿಪೀಟ್ ದಿ ಕ್ವಶನ್. ವಿಚ್ ಒನ್ ಆಫ್ ದಿ ಫಾಲೋಯಿಂಗ್ ಈಸ್ ನಾಟ್ ಎ ಫಂಕ್ಷನ್ ಆಫ್ ಎ ಸಾಲ್ಟ್ ಬ್ರಿಡ್ಜ್ ಟು ಅಲೋ ದಿ ಫ್ಲೋ ಆಫ್ ಕ್ಯಾಟಯಾನ್ಸ್ ಫ್ರಮ್ ಒನ್ ಸೊಲ್ಯೂಷನ್ ಟು ದಿ ಅದರ್ ಸೊಲ್ಯೂಷನ್? ಆಪ್ಷನ್ ಎ. ಆಪ್ಷನ್ ಬಿ, to allow the flow of anions from one solution to the other. Option C, to allow the electrons to flow from one solution to the other. Option D, to maintain electrical neutrality of the two solutions. So, very important. From this we can understand that what are the functions of the salt bridge. Salt bridge maintains the electrical neutrality. That is correct. It allows the movement of ions from one solution to another solution to maintain again electrical neutrality, so that anions can move from one solution to another, even cations can move from one solution to another. But salt bridge is made up of glass. Glass is a bad conductor of electricity. It doesn't allow the movement of electrons from one solution to another solution. Therefore, in option C, they have given to allow the electrons to flow from one solution to the other. That is not the function of the salt bridge. Next, if the salt bridge is removed suddenly from the working cell, the voltage increases, option A, decreases, option B, drops to 0, option C, may increase or decrease depending upon the cell reaction. If the salt bridge is removed suddenly from the working cell, the voltage drops to 0 because there is no connection between the two electrodes. Salt bridge gives the connection between the two electrodes, then only voltage is, the EMF is produced. So that without salt bridge, voltage drops to 0. Next, one small problem based on the Daniel cell or galvanic cell. A cell is formed by the combination of magnesium electrode and zinc electrode. Their reduction potentials are respectively minus 2.36 volts and minus 0.76 volts. The EMF of the cell is. Here options what they have given: A plus 1.6 volts, B minus 1.6 volts, C plus 3.12 volts, option D none. In this problem, I have given the standard reduction potential of magnesium. E naught of magnesium is given minus 2.36 volts. Standard reduction potential of zinc is given, Zn is given minus 0.76 volts. What is the standard cell potential? That means EMF of the cell. EMF of the cell is, that can be calculated by E naught of cell is equal to E naught of cathode minus E naught of anode. This is generally we are writing. Among the two values, you should decide which one is higher. Higher number with negative sign becomes the less value. Therefore, less value acts as the anode, more value acts as the cathode. When these two are combined, zinc electrode acts as the cathode, magnesium electrode acts as the anode. Therefore, E naught of zinc minus E naught of magnesium. Zinc value is minus 0.76 minus of minus 2.36 volts. So that here you will get plus 1.6 volts. So according to our calculation, plus 1.6 volts is the